Hello, everyone. Thank you for being here. I hope you're having a good time on the last day. I certainly have. I haven't been here in, I guess, 5 years now to reInvent. Hope you're having a great time. My name is Bruce Momjan. I work for EDB. We have a booth. We're out in the corner where you enter the the keynote area right down there. But I've been with them for 17 years. And I've been working with Postgres for 27 years. Long time, long time. I'm one of the core team members. I speak at about 30 events a year, travel about 90 days a year. And we actually have a big conference coming up in 2 weeks in Prague. We had one last 2 months in New York City, and then we have one in Brussels, and then I think San Jose and Chicago and Los Angeles and Vancouver out toward May. So again, we're really a busy, very active community. But today I want to just talk to you about Postgres. We're going to have time for Q&A, so I hope we can do that together. I'm glad they have the closed captioning out there because it's kind of hard to hear. There's so much noise. I wish I could fix that, but we're going to do our best. Oops, sorry, wrong button. Yeah. So the theme of this is you should be using more Postgres. Now, I'd love to think that I made this up, but there's actually another speaker who was supposed to be here today, and he got sick, so they put me up here, and I have the honor of getting to talk to you about this. I have a lot of history with this project, so I can kind of give you some ideas, and at the end we can get some questions from the audience, which is always the most interesting part for me. This is kind of a crazy slide. This is from 1986. Okay, so in 1986, I think I had graduated college, probably a couple years before that. I bet there's not much software here whose fundamentals were set in 1986. And it's kind of shocking. Again, I've been with Postgres for 27 years, but Postgres actually goes back 37 years to 1986. And this is sort of the foundational document by Michael Stonebreaker. His name is right here, out of the University of California, Berkeley. And what he's talking about here is a post-relational database. Now, that may mean nothing to you, but by the end of this talk, I think you'll understand why that's important. And hopefully you'll think I'm not making this up, that actually it is important, okay? And I'll try and explain why. So I was a history major in college, so I kind of look back at history. So if you look at the history of relational systems, they really started in the 1970s with COD and sort of the relational model. You had System R, and you had Ingress, which is a very early database, also from University of California, Berkeley. But what happened in 1986 is Michael Stonebreaker said, you know, these relational systems that we're making are too rigid. They don't allow you to expand the database to handle data types and indexing and stored procedure languages and that are specific to the problem space. So in a lot of ways, Michael Stonebreaker in 1986 was way ahead of his time, and I'm going to explain that as we go. But he saw, again, 37 years ago, that the traditional relational system was insufficient for the evolving workloads of enterprises, all right? Now, he dealt with some kind of bizarre things as well. He was worried about optical disks. I don't think anybody's worried about that anymore. But he did have the other important idea, and that was make it easy to extend the database, all right? And I'm going to explain to you in a minute why that is so important to Postgres today. New data types, new operators, new indexing methods, These are all things that were built into Postgres in 1986. And when I started in 1996, this stuff was a pain, right? It made our job really hard because you were working in the source code and everything was abstract. Everything was like, this is not an integer, it's a row in a table. This isn't like a B tree, it's a row in an indexing type table. And we carried that code for 10, 15 years, really not making much use of it. But what happened dramatically is that in about the 2010, 2005, you started to see a lot of change of what relational systems were required to do. Instead of storing just data entry or order entries type of applications, you had data warehouse needs. That was the first one. Then you had people who were trying to put full text, documents in the database. So you needed full text search. You had GIS data. You had to put GIS data in the database. You had JSON data coming from web applications. You needed to put that in the database. And the problem was that every other relational system except for Postgres wasn't designed to be extendable. So every time a new requirement came, they had to kind of bolt on JSON or bolt on GIS or bolt on full text search. The bizarre thing and the thing that makes Postgres look so amazing is that we already had all of this unused in the code. And when these new data requirements came, we were ready. Again, a lot of these systems have already done extendability. So the big point is not only has Postgres been around for 37 years, but instead of looking like a 37-year-old piece of software, it actually looks like something that was done like modern, right? The other key thing is because we're an open source project, we have people from all over the world working 24 hours to make that source code look as clean and as neat and as efficient as possible. So if you look at the Postgres source code, it's not going to look like some old crufty thing. It's continually, people all over the world, continually getting improved on. And I'm just going to walk through this and I'm going to try and explain why this happened. But even in the short period, the last 6 years, okay, you have Postgres kind of trailing Redis and these other databases, same thing over here. 2008, again, we're trailing a little less. 2019, again, a little tighter. MySQL down there, okay? 2020, again, even closer. 2021, almost. 2022 is effectively where we go. And then 2023, you can see, looking at this, we're probably like way beyond what other people do. And there's a couple reasons for this. The first reason, as I said before, is the extendability of Postgres has allowed us to make seamless use of NoSQL data, data warehouse, full text search, GIS, all the things that modern range types, which I'm not even going to go into, all the modern structures that are needed to store today's data. We don't have to rewrite the database to add JSON. We don't need to rewrite the database even to add a new indexing method or a new stored procedure language. That infrastructure is already there. We just plug in a new, and usually plugins for databases never work right. They don't back up right. They're kind of awkward. They only work in certain circumstances. But because our structure is that way, that's allowed Postgres to really become the de facto standard now for relational systems. The other things that I think really, the three other things that really made a big difference is that first, we're an open source community. And it's always kind of confused me. Like, we're an open source community. We have no money. We have no assets. We don't have any employees. But we're able to produce software better than billion-dollar companies, right? And the reason for that is the efficiency of what we do and the way we harness the best ideas from around the world is really impossible to compete against, okay? So for example, MySQL did pretty well in the 2000s, but again, they were controlled by a company. They weren't leveraging an open source sort of movement and process. And over time, those companies controlled by single companies, they do well, but they don't last. And they kind of peter out because you can only run at that speed for so long and then just kind of start to limp down. And we see this all over the place. And I'll show you in a minute. The other thing is that Oracle is treating its customers terribly. And the reason for that is because they probably don't think they're going to be customers for very long. Like, if you want to keep your customers, usually you treat them pretty well. I think Oracle knows that the life of the database market is not in their favor. So they're starting to treat them badly. So those are probably the four things: the extensibility, the open source, the problem with MySQL and the whole uncertainty there, and then Oracle treating people badly. And of course, my company, EDB, helps people move Postgres into the enterprise, including typical Oracle workloads to the enterprise. And again, another chart talking about this. So again, incredibly popular database. These are some of the companies that help support Postgres, okay? You're not gonna see a couple logos here, but this is a Russian company. This is in US, this is international, this is Japan. We know this one. These guys are in Austria, and I believe this is Brazil. So again, you get a chance. Oh, this is Japan as well. This is California. So again, you have a lot of companies that are working around this entire Postgres ecosystem. And what they're doing, particularly EDB, is that the open source software is great, but if you need somebody, you need support. You need tooling to deploy hundreds or thousands of databases. You need monitoring. You need backup tools. You need training. You need somebody to come in and look at your infrastructure. The community can't do any of those things, right? Because we're not a company. Like, you don't pay anybody. So you need these companies, and I continue to talk to these companies, even though I work with EDB. Just today, I was talking to somebody from Percona. How can we make you successful? How can I help you? Even as an EDB employee, how can I help Percona become successful in this market? Because the more of these people we have, the better Postgres is. So the great thing is it's not controlled by a single company. Our company does do a lot of contributions to Postgres. Probably like 20% of contributors a year come from this, and we've done all these kind of cool things with it. But again, there's a lot of others, and we want as many as possible. Again, we're trying to leverage the brain power of so many people to get into our project. And you know, you start this 27 years ago and you have maybe 100 or 1,000 users, and you do that consistently for 27 years, and all of a sudden you're like, wow, I'm at Amazon reInvent, and all these companies want to help us. So again, there's a huge commercial community. Our booth is down in the corner there again. One of the reasons that Postgres is so popular is we have a very company-friendly license. This is the entire license. It's not a cutoff. This is it, okay? And it's basically saying you can pretty much do anything you want, okay? So companies like that, they can contribute to Postgres, or they can take the code and just leave. It's up to them. The good thing is they often come back to help, okay? So it's actually open source. It's not controlled by a single company. All the cloud platforms support us. You might think it's kind of weird. We've got just AWS here. I was not allowed to put any other cloud vendors up here, but the other cloud vendors are, of course, Amazon, Azure. We have Google Cloud. We have Alibaba out of China. We have Oracle Postgres. So you can run Postgres in Oracle Cloud from Oracle, okay? So if that does not tell you that Oracle realizes that Postgres is the future, I don't know what is. You don't bring in another piece of software unless you actually think that that's meeting a need that your database software is not meeting, okay? Another thing that's made us tremendously popular is that our architecture is very good for the cloud. It's very easy to deploy. There's no licensing. It's a very lightweight infrastructure, the way it's installed. Installing Oracle typically is a very hard thing. It's very easy. Not only does Oracle support us, I mean, how many relational databases are there? There's Oracle, they support us. There's Microsoft, they support us. There's DB2, IBM supports us. I don't know who doesn't support us now. Oracle was the last holdout. That changed probably 2 months ago. If you look up my blog entry, you can see details about that. So Postgres is where you need it. And finally, just to kind of get into some, I know this slide, I did not pick this slide, so I'm sorry about that. But that's kind of weird. Okay, that's okay. So the basic issue is that the typical data stack is incredibly complicated. And the reason it's incredibly complicated is because each piece is typically doing one thing, all right? So you end up with this really weird structure of what, now you're gonna get this weird structure if you're doing AI, you're gonna get this weird structure if you're doing JSON, you're gonna get this weird structure if you're doing full text search, you're gonna get this weird structure if you're doing data warehouse, okay? But the cool, and again, it's this crazy thing, but the cool thing is that you need to be nimble, and what Postgres allows you to do is to kind of shrink that window so you don't have that problem, all right? So, again, the last thing I want to say, again, our company does multi-region Postgres, online maintenance, zero downtime upgrades, Oracle compatibility, self-managed cloud product, and again, leading contributor to Postgres. The last thing I want to say is we have a 5 p.m. event over at the Mirage. If you'd like to come, community meetup, sponsored by this guy here from a different company. So if you want to either scan that QR code or go up to our booth, we have little papers. I think I have. Let's not do that. Let me not do that again. But again, if you want to attend this event at 5 p.m., please do that. I think we have time for 1 or 2 questions. Let's do that.
Yeah, if anyone's got a question, let me know. I'll come over with the mic.